आज हम लोग इस वीडियो में सेंटर ऑफ प्रेशर के बारे में पढ़ेंगे। पिछले वीडियो में हमने टोटल प्रेशर के बारे में पढ़ा हुआ है और आज के इस वीडियो में हम लोग सेंटर ऑफ प्रेशर के बारे में पढ़ेंगे। तो स्टार्ट करेंगे। द सेंटर ऑफ प्रेशर इज द पॉइंट वेयर द टोटल सम ऑफ द प्रेशर field acts on a body, causes a force to act through that point. The total pressure vector acting at the center of pressure is the value of the integrated vectorial pressure field. The resultant force and center of pressure location produce equivalent force and moment on the body as the original pressure field. Pressure field occurs in both static and dynamic fluid mechanics. Specification of the center of pressure, the reference point from which the center of pressure is referenced, and the associated forces vectors allow the moment generated about the any point of B computed by translation from the reference point to the desired new point. It is common for the center of pressure to be related or located on the body, but in which flow of fluid is possible for the pressure field to exert a moment on the body of such magnitude that the center of pressure is located outside the body. Center of pressure on an inclined immersed surface. Consider a plane inclined surface immersed in a liquid as shown in the figure. First of all, let us divide the whole immersed surface into a number of small parallel strips as shown in the figure. Let V W is the specific weight of the liquid, A is the total area of the immersed surface, X is the depth of center of gravity of the immersed surface from the liquid surface, theta is the angle at which the immersed surface is to be inclined to the liquid surface. Then let us consider a strip of thickness x dx, width b, and depth of at a is depth into from the free surface of the liquid. Now the intensity of the pressure on the strip equal to WL sin theta and area is equal to P into dx. So pressure on the strip P is equal to intensity of pressure into area WL sin theta into B dx, and moment of the pressure at O equal to WL sin theta into B dx into L equal to WL square sin theta into B dx. So M is equal to integration WL square sin theta into B dx equal to WL theta integration L square into B dx. But integration L2 equal to L2 B dx equal to I, that is moment of inertia of the surface about 0. So M is equal to W sin theta I. We know the sum of the moments of all such pressures about 0 equal to pH bar divided by sine theta, where P is the pressure of the total pressure of the surface and H is the depth of center of pressure from the liquid surface. Center of pressure on an inclined immersed surface. Now equating equation 1 and 2, pH bar divided by sine theta equal to W sine theta I. Now W A x bar into H bar divided by sine theta equal to W sine theta I. So H bar equal to I sine square theta divided by A x bar. We know the theorem of parallel axis that I is equal to Ig plus A square, where Ig is the moment of inertia about the figure about the horizontal axis through its center of gravity. H is the distance between the liquid surface and the center of gravity of the figure. Now rearrange the equation. Third, H bar equal to sine square theta by Ax bar into Ig plus Al1 square equal to sine square theta about upon Ax bar into Ig plus A in bracket x bar upon sine theta bracket close square bracket complete into bracket 1 equal to x bar upon sine theta bracket close, then h bar equal to Ig sine square theta upon a x bar plus x bar. So here the uh, our center of pressure is finished. So we are stopping the our video. We will see the next video about the second chapter, that is the fundamentals of fluid flow and flow measurement. So thank you for watching this video. Wait for the second chapter, fundamentals of fluid flow and flow measurement. Okay, bye bye. So thank you for watching this video. आपको अगर वीडियो अच्छा लगा हो तो लाइक शेयर और सब्सक्राइब कीजिए। आपको कोई डाउट हो तो कमेंट सेक्शन में आप पूछ सकते हो। तो धन्यवाद, मिलेंगे हम दूसरे वीडियो में।